Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will speak about estimating limits graphically. The first point of this lesson is to know that each point has two coordinates. The first one is x and the second one is y. We are speaking about now the second one. When we are going to find the limit of any function, we are speaking about y-axis, coordinate. The y-coordinate here is speaking about how much the point is above x-axis or below x-axis when x goes to one value. Maybe it will be 0, it will be 2, as they ask us to find the limit. Here he asks us to find or to estimate the limit of negative 3x plus 1 when x goes to or approaches to 2. Now, by using this table, we can find that the value of f of x become closer and closer to the value of, look at the values of f of x. Here it is negative 4.7. Here, when we become closer to the point 2, at 1.99, the value of f of x equal negative 4.97. When x goes to 2 and closer to 2, it is now 1.999. The value of f of x equal negative 4.997. It is closer to the point negative 5. And also when we come from the right, when the value of x is 2.1, the value of f of x equal negative 5.3. When the value of x equal 2.01, the value of f of x equal negative 5.03. Here we are closer to the point 2, 2.001. The value of f of x at this point is negative 5.003. It is so closer, or it is closer to the point negative 5. So we can now estimate the limits of the function negative 3x plus 1 as negative 5. In this example now, the guide practice of the example number 1, he asks us to find the limit of 1 minus 5x when x approaches to negative 3. By using this table, by the same way, we can conclude that the limit of the function 1 minus 5x is closer to 16. Look at the line. When we are going to the point negative 3 here, from the right, the height of the point become closer and closer to the point 16, and from the left, if I come from the left, the value of f of x come and closer and closer to the point 16. Guide practice of example number 1, the second one. Find the limit of x squared minus 1 when x approaches to 1 by using this table, some values below 1 and some values up of 1. We are trying to estimate the value of f of x when the value of x come closer to 1 beside neighborhood or neighbor to the point x equal 1. Type. Look at the graph. We know that the x squared minus 1 is the quadratic function. It is parabola, and it has a y-intercept of negative 1, and it is passes through the point 1, 0. So look at the table. 0.99, 0.999. Look at the values of f of x. It is negative 0.0199. Here it is negative 0.001999. So it is, or it is going to be what? 0, as we see in the graph. Now, in example number 2, he asked us to find the limit when when the limit is not equal to fc. Look at the question. He asked us to find the limit of x squared minus 9 over x minus 3 when x approaches to 3. It means that the value of the denominator equal to 0. So when we have fraction and the value of the denominator is equal to 0, the value of the fraction is undefined. So we are going now to find the limit of this function when x approaches to this point, the value of x that makes a fraction undefined. Look at the table here. When x approaches to 3, 2.9, 2.99, 2.999, the value of x is 5.9, 5.99, 5.999. It is going to be what? Yes, it is going to be 6. Here and also from the right hand side. 3.1, the value of x. 3.01, the value of x. 3.001, the value of x come closer and closer to be 3. And the value of y, 6.1, 6.01, 6.001, it is going to be what? Yes, it is going to be 6. Look at the graph. In the graph, we can see that the value of f of x, when x approaches to 3, it is, yes, it is 6. But we don't have here a value of the fraction, because when x equal to 3, the fraction is undefined. The guided practice of example number 2a, he asked us to find the limit of x plus 2 over x squared minus 4 when x approaches to negative 2. Look at the table. Use the table to prove that the limit is going to be what? Here, negative 1.99, negative 1.999, negative 2 and negative 2. Look at the value of f of x. It is negative 0.2506 and negative 0.2501. It is going to be what? Negative 0.25. Also from the right, negative, the value of x, negative 2.01, negative 2.001, and the value of f of x going to be what? Negative 0.2494, negative 0.2499. It is going to be negative 0.25, just like the graph here. It is not on the half, it is in the quarter, but it is below x-axis. The guided practice of example number 2b, he is asking us to find the limit of x squared minus 4x minus 5 over x minus 5 when x approaches to 5. By using the table, we can find that the value of x as x goes to 5 from the left, the value of f of x is going to be 6, and as x going to be 5 from the right, the value of f of x is going to be 6. So the limit of the fraction here is 6, but is it defined or not undefined? Yes, it is defined, because if we replace, when x goes to 5, the value of x equal to 6. So I replace 6 by x, so it is defined. But when we replace x by 5, it is undefined. But the limit from the left is equal to the limit from the right. So we have limit here.